Okay, so we're here with our first online lesson that we have. So in the second half of the course, we cycle back through outcomes 1 through 6 and finish those all off. So we're going back to outcome 1. We'll finish that one up this week and get our assessment done on it. It's working with numbers. We did a skill review that I posted just before the break that you can go back and look at to recap the first 3 lessons, but here we are on lesson 4. So we're looking at proportions and solving proportions. Usually it comes from, we're looking at word problem context, sorry. And so basically what we're looking at is taking the information in the problem and making fractions out of it. So I first want to introduce the different kinds of fractions you can usually make with 2 numbers. So there's 13 cats and 12 dogs in the pound. What fractions can we make with this information? The 2 that I usually get from people is I can make the fraction 13 over 12, and that's showing the ratio of cats to dogs. The other one we could make is flip it the other way, the ratio of dogs to cats. So those are the 2 that I usually get when I ask this question to a class. Now, there's actually 2 more fractions that we need to make, need to recognize are there. And those are the fractions 13 out of 25, and that's the ratio of cats to total. So with 13 and 12, there's a total of 25 animals. So sometimes the problems are going to need the total involved. And the other one then would be 12 out of 25. That's the dogs to total ratio. So these first 2 are called parts to parts ratios. And these 2 are parts to whole or parts to total, however you want to say it. So the second 2, very useful in getting percentages. If you wanted to know what percentage were cats or what percentage were dogs, you have to use these second 2. And sometimes based on the information in the problem, you need to use a total instead of a parts to parts. So I'll look at setting up the first problem here. In a math class at Westside, 13 students have iPhones and 7 students have Android phones. So those are both parts. The total there is 20. We might not need the total though, so let's see. Assuming this ratio holds true for the entire school, approximately how many people in the school have iPhones if 230 people have Android phones? So just to recognize the pattern in the starting information, we've got 2 numbers giving us this starting ratio, 13 to 7. To figure out whether I need a parts to parts or parts to total, I look at the other piece of information usually, and it's asking 230 people have Android phones. So it's not talking about the total number of students in the school. It's talking about, again, one of those parts. It's talking about just Android there. So I can make any parts to parts fraction to start out. So I usually just write them in the order that they show up, 13 to 7, and that's the ratio of iPhones to Android. So that's my little fraction. That's my sort of one class. And then I'm going to say, well, if that's going to hold true, it's going to be equal to another proportion, another ratio, and the other number we have is 230. So what all you have to do is put it in the right spot. So the top is iPhones, the bottom's Android. 230 people have Android phones, so it's got to go on the bottom. I usually put an X on top. So again, you can solve this. I've got 2 ways to solve this. You could do scale factor, and that would be figure out what do you times 7 by to get 230. But I really like the crisscross method. I think that's the fastest, easiest way to do it. So again, the crisscross method, you draw an X top to bottom, bottom to top. You will always get 2 numbers that connect to each other. So in this case, it's 13 and 230. You multiply those 2. You divide by the last number out. That'll always solve that proportion for you without having to figure out the decimal and all that sort of stuff. So 17 times 230 divided by 7, and my calculator spits out 427.1. Now obviously we can't have 0.1 of a student, and that's because probably the ratio in one classroom doesn't exactly match the whole school, and that's sort of what this is showing here. So I would answer this, therefore about 427 students have iPhones. And I'll just double check. In the starting ratio, iPhones was bigger. In the ending ratio, iPhones is still bigger. So that's a good check that we haven't mixed up the spots. Okay. Next one. In one order of chicken wings, there were 14 drummies and 8 banjos. So these are the names of the different types of chicken wings that actually my wife's family uses. So you've got the one with the single bone in it and sort of the round clump of meat on it, the drumstick, the drummy. The other ones with the 2 bones in it, some people call them flats. My wife's family always called them banjos, so I use banjos in this problem. But one order of chicken wings had 14 of one and 8 of the other. The restaurant served 144 drummies in one evening. Approximately how many banjos did they serve? So I'll ask you to just pause my video right now, see if you can set up the 2 fractions for this and solve it, and then unpause, and I will show you my solution. All right, so again, 14 drummies and banjos are our 2 things in the problem. They're both the parts, and the second piece of information isn't a total, it's a part. It's the amount of drummies. So I would set it up this way, and that's my ratio of drummies over banjos in that order. 144 is an amount of drummies, so it has to go on top. X goes on bottom. Crisscross applesauce here. We're going to multiply the 8 and the 144 and divide by 14. And again, I get a decimal answer here. 82.3 it rounds to. So again, therefore, about 82 banjos were served. So that's that one. And again, you can pause, read the second one here, and see if you can set that one up on your own and get the answer. Okay, so in one order of chicken wings, there were 14 drummies and 8 banjos. Same starting information, it's the second piece of information that's different. The restaurant served 98 chicken wings one evening. So it's given us a total for our second piece of information. Well, I guess our third piece of information there. So that means we need to use a parts to total ratio to solve this one out. So I always put total on the bottom because if we're going to do a percent at any point, you need the total on the bottom anyway. So I just always put the total on the bottom. Doesn't matter really. So we're going to make the ratio of total on the bottom. And since it's asking about drummies, we're going to put drummies on top. So we have 14 drummies in our base order. And that order has a total of 14 plus 8, 22 chicken wings in it in total. And that is going to equal 98's the total, and X goes on top. Now we'll do our crisscross applesauce. X is 14 times 98 divided by 22. And I get 62.4, so then therefore about 62 drummies. All right, so that's how you do one that needs a total. So the second part of the PDF that I posted is the practice questions. There's only a few on this one. What's that? Six questions there. And I will get you to send me a picture of your answer to to the first one, and to that one as well, so I can see one of each type. So send me your answer to A and E when you get it done. So just take a picture, either email it or send it to me through Google Chat.